Hello students, welcome back. Today we will start exercise 3.4 of chapter number 3, that is trigonometric function. Okay, so let's start. Find the principal and general solution of following equation. So first one is 10x equal to root 3. First one. 10x equal to root 3. Now see, you have to find out principal and general solution. Okay, so we know that the value of 10 pi by 3 is equal to root 3. So that is equal to 10 pi by 3. Okay, so here alpha, I will find out this is equal to pi by 3. Now, this value is positive. 10 is positive in first and third quadrant. Right, so principal solution will be first alpha and second third quadrant means pi plus alpha, so that is equal to pi plus pi by 3. So 3 pi plus pi, that is 4 pi by 3. So principal solution, that is equal to pi by 3 and 4 pi by 3. Remember our technique, first find out the angle alpha from the first quadrant, means alpha such that 0 less than alpha less than pi by 2. Okay, here it is positive, so we found out that. Clear? Then alpha and pi plus alpha, first and third quadrant. Clear? Now for general solution. For general solution, the formula for 10 is x is equal to, it's 10, so n pi plus alpha such that n belongs to z. And here what is alpha? Pi by 3. So x is equal to n pi plus pi by 3 such that n belongs to z. Okay, you can also write down k pi plus pi by 3, k belongs to z, where n, here n is an integer. Clear? So this was about question number 1. Note it down. Now let's move to the next, that is question number 2. Question number 2, that is sec x is equal to 2, right? So now let's convert it into cos x. Cos is reciprocal of x, so cos x is equal to 1 by 2. Find out the value of alpha. Where does the value of cos is? 1 by 2. Okay, cos 1 by 2, that is equal to 60 degree, that is pi by 3. So this is equal to cos pi by 3. Right, now cos is positive in first and fourth quadrant. Here I will say alpha is equal to pi by 3, and in fourth quadrant, so for fourth quadrant I will take 2 pi minus alpha. Right, remember this, for first quadrant alpha, second quadrant pi minus alpha, third quadrant pi plus alpha, and fourth quadrant 2 pi minus alpha. So it's 2 pi minus pi by 3, that is equal to 6 pi minus pi, 5 pi by 3. So the principal solution means between 0 and 2 pi. Principal solution is x is equal to pi by 3 and 5 pi by 3. Clear? Now for general solution. General solution for cos x is equal to 2n pi plus minus alpha n belongs to z. So here alpha is pi by 3, so 2n pi plus minus pi by 3 such that n belongs to z. Okay, so this was the second one. Note it down. Now let's move to the next, third. cot x equal to minus root 3. Let's change it to 10. That implies 10x is equal to minus 1 by root 3. Okay, so now say here it's having negative value. So what we can do, first find out when the value of 10 is 1 by root 3. Okay, the value of 10 will be 1 by root 3. Clear? It will be at 30 degree, that is pi by 6. So I'm writing in short here alpha is equal to pi by 6. In actual case, this is not equal to 10 pi by 6. Okay, remember, in actual case, it is not equal to 10 pi by 6. Okay, I'm writing when alpha is equal to pi by 6. At that time, 10 alpha will be equal to 1 by root 3. Okay, but now we are having minus 1 by root 3. So 10 is negative in second quadrant and fourth quadrant. So for second quadrant, I will take pi minus alpha, that is pi minus pi by 6, that is equal to 6 pi minus pi, 5 pi by 6. And for fourth quadrant, this is for second quadrant, and for fourth quadrant it is 2 pi minus alpha, so that is equal to 2 pi minus pi by 6. So this will be equal to 6, so 12 minus pi, 12 pi minus pi, 11 pi by 6. Okay, so what is the principal solution? Principal solution here is x is equal to 5 pi by 6 and 11 pi by 6. Clear? And for general solution for 10, what we are using, x equal to n pi plus alpha such that n belongs to z. So here it will be x equal to n pi plus it's 5 pi by 6. See here I'm getting 5. I cannot take here pi by 6. Remember, this is pi by, when we will take pi by 6, it is 1 by root 3. Clear? So I need to take this value for negative. So it will be n pi plus 5 pi by 6 such that n belongs to z. So I'm just erasing this so you don't get confused that you have to put alpha. Okay, which value you have to put here? The first principal solution. Okay, so this is about cot x equal to minus root 3. Here, so note down question number third. Now let's move to the next one, that is question number 4. Question number 4 is cosec x equal to minus 2. Okay, so first let's convert into sine. That implies sine x is equal to minus 1 by 2. Okay, so now see here, when I take alpha, when the value of sine is 1 by 2, 30 degree, that is pi by 6. So when alpha equal to pi by 6, sine alpha is equal to 1 by 2. Clear? Now sine we are having minus 1 by 2. So in which quadrant sine is negative? Sine is negative in third quadrant and fourth quadrant. So for third quadrant, okay, I will use pi plus alpha, that is pi plus pi by 6, that is equal to 6 pi plus 1, 7 pi by 6. And second, fourth quadrant. For fourth quadrant, I will use 2 pi minus pi by 6. So this will be equal to 6 to the 12 minus 1, 11 pi by 6. Okay, so the principal solution is x equal to 7 pi by 6 and 11 pi by 6. Okay, the general solution. For general solution, the formula was For sine, it is x equal to n pi plus minus 1 raised to n alpha. Here it's not alpha, we will take 7 pi by 6. Okay, that is the first angle. 7 pi by 6 such that n belongs to z. Here, so this is the principal solution and general solution. For sine, you know, it's n pi plus minus 1 raised to n into the angle. Okay, so note down question number 4. Now let's move to the next, that is question number 5. Okay, the next, find the general solution for each of the following equations. See, now you don't have to find out the principal solution. Okay, so first let's say fifth one, that is cos 4x minus cos 2x. Cos 4x equal to cos 2x. Okay, so now what I will do, I will take cos 2x on this side. So cos 4x minus cos 2x equal to 0. Now I will use the formula C minus C. C minus C minus 2SS. So this implies minus 2 sine 4x plus 2x by 2 cos 4x minus 2x by 2. Sorry, minus 2ss. Sine upon 2. This is equal to 0. So what does this imply? Minus 2 sine 4x plus 2x 6x by 2 3x. Sine 4x minus 2x 2x by 2 x equal to 0. Okay, when this minus 2 goes here, 0 divided by minus 2, it will be 0. So that implies sine 3x into sine x is equal to 0. So what does this imply? Either sine 3x is equal to 0 or sine x is equal to 0. Okay. Now for zeros, when does the value of sine is 0? You know that if this is unit circle, this is unit circle. Okay, that at these two position the value of sine is 0, means n pi. Okay, sine is 0 at, for zeros, sine n pi, cos 2n plus minus 1 pi by 2, and for 10, when sine is 0, 10 is 0, again is n pi. Okay, so now sine x equal to 0, that implies x is equal to n pi and belongs to z. And here sine 3x equal to 0, what is the angle? 3x. So that means 3x is equal to n pi. Okay, that means x is equal to n pi by 3 or n pi. Okay, and here n belongs to z. Okay, remember here the angle is 3x, so you cannot take directly x equal to 0, x equal to n pi. You have to take 3x equal to n pi. Clear? So this was about question number 5. Note it down. Now let's move to the next, that is question number 6. Question number 6. Cos 3x plus cos x minus cos 2x equal to 0. Okay, so first here I will use the formula c plus c. C plus c, 2cc. So 2 cos 3x plus x by 2 cos 3x minus x by 2 minus cos 2x is equal to 0. So 2 cos 3x plus x, that is 4x by 2 2x cos 3x minus x, that is 2x by 2 x minus cos 2x is equal to 0. So I can take cos 2x common here. So cos 2x is common and 2 cos x minus 1 is equal to 0. So what does this mean? Cos 2x is equal to 0 or 2 cos x minus 1 equal to 0. 2 cos x minus 1 equal to 0, that means 2 cos x equal to 1. That means cos x is equal to 1 by 2. Okay, so what do I get? I got either cos 2x is equal to 0 or cos x equal to 1 by 2. Now cos, when does the value of cos is 0? We had already done, we have discussed this. It is 2n plus minus 1 pi by 2. So this implies 2x is equal to 2n plus minus 1 pi by 2. Or cos x is equal to 1 by 2. When does the value of cos is 1 by 2? Cos pi by 3. Right, so here alpha is pi by 3, so x is equal to, for cos we were using 2n pi plus minus alpha, that is pi by 3. Okay, so here when I will solve it this further, I will get x is equal to 2n plus minus 1 pi by 4. Okay, when this 2 when goes on this side, it will be divided. So x is equal to the general solution 2n plus minus 1 pi by 4 or 2n pi plus minus pi by 3 such that n belongs to z. Clear? First I used the formula of c plus c 2cc. I took 2 cos 2x common. Then we are split in two parts. Either cos 2x is equal to 0 or cos x equal to 1 by 2. This we used, which we used in earlier sum for general formula. And this we use zeros of cos. Cos is 0 at 2n plus minus 1 pi by 2. When this 2 goes this side, it will be divided. Okay? So note down question number 6. Now let's move to question number 7. Question number 7. Sine 2x plus cos x equal to 0. Okay, here we'll use the formula for sine 2 theta. What is the formula for sine 2 theta? Sine 2 theta was equal to 2 sine theta cos theta. Okay, so here we will get 2 sine, reduce the angle to half, so it's 2x. I will get x cos x plus cos x equal to 0. Okay, so what I can do, I can take cos x common. I will get 2 sin x plus 1. This is equal to 0. So what does this mean? This means that either cos x is equal to 0 or 2 sin x plus 1 is equal to 0. So cos x is equal to 0. Where does the value of cos is 0? We just did it in the earlier sum. X is equal to 2n plus 1 pi by 2. So that n belongs to z. In this case, sin x, 2 sin x equal to minus 1 or sin x is equal to minus 1 by 2. Now it's negative, so it will be in third quadrant. Now what is the, when is the value of sine is 1 by 2? 30 degree, that is pi by 6. So for third quadrant, I will take pi plus alpha, that is pi plus pi by 6, 7 pi by 6. So I can write down this is equal to sine 7 pi by 6. So this is our alpha. So in this case, x will be equal to n pi plus minus 1 raised to n alpha, that is 7 pi by 6. Okay, so that means the general solution is x is equal to 2n plus 1 pi by 2 such that n belongs to z, or n pi plus minus 1 raised to n 7 pi by 6 such that n belongs to z. Okay, so this was about question number 7. So just note it down. Now let's move to the next question, that is question number 8. Question 8. Sec square 2x equal to 1 minus tan 2x. Okay, now here it is tan and here it is sec. So let's convert this sec square into tan square. Okay, sec square theta is equal to tan square theta plus 1. Okay, we know that sec square theta is equal to tan square theta plus 1. So here I can write it down tan square. What is theta? 2x plus 1 equal to 1 minus tan 2x. So 1 will get cancel. Okay. So now let's take this tan 2x here on this side. Tan square 2x plus tan 2x is equal to 1. So taking tan 2x common, I will get tan 2x plus 1, sorry, not 1, it will be 0, is equal to 0. Okay, so either tan 2x is equal to 0 or tan 2x plus 1 is equal to 0. See here the angle is only 2x. It's not tan of 2x plus 1. It's tan of 2x plus 1. Okay. So now when does the value of tan is equal to 0? When sine is equal to 0, that is n pi. That implies x 2x is equal to n pi, or x is equal to n pi by 2. Okay, or tan 2x is equal to 1, that means tan 2x equal to minus 1. Okay, now when does the value of tan is plus 1? Pi by 4. Now minus 1, in which quadrant tan is negative, second and fourth? So we have to select the first one, that is second quadrant. For second quadrant we will use pi minus alpha. Pi minus, when does the value of tan is 1? Pi by 4. So it is equal to 3 pi by 4. So this is equal to 10 3 pi by 4. Now this is our alpha. So 2x is equal to, for 10 it is n pi plus alpha, that is 3 pi by 4. Okay, that means x is equal to n pi. This 2 I will divide it when it goes on this side by 2 plus 3 pi by 4 to the 8 such that n belongs to z. Clear? So the general solution is x equal to n pi by 2 such that n belongs to z, or n pi by 2 plus 3 pi by 8 such that n belongs to z. Clear? So this was question number 8. Just note it down. Let's move to the next, ninth. That is the last for this exercise. 9. Sin x plus sin 3x plus sin 5x equal to 0. Okay, now see, here I will use s plus s. But see, when I will use in this, if I will use it in these two, then x plus 3x, 4x by 2 will be 2x, x minus 3x minus 2x by 2 will be minus x. Then again here it is sine phi x. But instead of these two, if I use sin x plus sin phi x, then sin x plus sin phi x, sorry, x plus phi x, 6x by 2 will be equal to 3x. So we can take common. So what I am doing, I am rearranging it, sin phi x plus sin x plus sin 3x equal to 0. Now I will use s plus s. So s plus s, 2sc, 2 sine phi x plus x by 2 cos phi x minus x by 2 plus sine 3x equal to 0. So this implies 2 5x plus x, 6x by 2, 3x cos 5x minus x, 4x by 2, 2x plus sine 3x equal to 0. I can take sine 3x common. So this will be equal to sine 3x. What is remaining? 2 cos 2x plus 1 equal to 0. Okay. So now what does this mean? Either sine 3x is equal to 0 or 2 cos 2x plus 1 equal to 0. Okay, first let's solve this. Sine 3x is equal to 0. For zeros, when does the value of sine x is equal to 0? Value of sine is 0 at n pi. So this implies 3x is equal to n pi and x equal to, when 3 goes on this side, it will be divided so that n belongs to z. This case 2 cos 2x will be equal to minus 1. When this 2 go on this side, it will be divided. Okay, so minus 1 by 2. The value of cos 2x is minus 1 by 2. When does the value of cos is 1 by 2? That is cos 60 pi by 3, and cos is negative in second quadrant. So pi plus alpha. Pi plus pi by 3. So 3 pi plus pi, 4 pi by 3. So this is equal to cos 4 pi by 3. Right? So 2x. I am not taking x, 2x. For cos it is 2n pi plus minus alpha. What is our alpha? 4 pi by 3. So x I will divide by 2. When 2 goes on this side, it is divided. So 2n pi by 2, n pi 2 gets cancelled. And here 2 ones are, 2 twos are. So plus minus 2 pi by 3. Okay, so the general solution is x equal to n pi by 3 such that n belongs to z, or n pi plus minus 2 pi by 3 such that n belongs to z. Okay, so this was question number 9. Just note it down. So here we completed exercise 3.4. Okay students, so that's it for today. In our next video lecture, we will start with the miscellaneous exercise. Thank you.